Y10. This lesson is about radioactivity, the three types of radioactivity. Instead of being called 1, 2 and 3, or A, B and C, they use the Greek alphabet, alpha, beta and gamma, written like that. Alpha, beta, gamma radiation. First of all, alpha radiation. Well, all of radiation occurs from the centre of the atom, the nucleus there. So everything is the nucleus, which means we're not bothered about the electrons going around the outside there. Let's forget about those for now. Three types of radiation. First of all, alpha. Sometimes a particle breaks off here, a chunk breaks off the nucleus. It's always made up, that particle, of 2 protons and 2 neutrons moving at high speed. It flies off at high speed like that. That is an alpha particle. Secondly, beta particle, what happens there? Well, suddenly a neutron turns into a proton. So, for example, this neutron here, or this one here, may suddenly turn into a proton. So it stops being a neutron and it becomes a proton. There's one more proton. In doing that, it also produces an electron, and the electron flies off at high speed. We call it a beta particle. It is just an electron moving at high speed, but it's called a beta particle. So that one is alpha, this one is beta radiation. And thirdly, gamma radiation is when all the particles in the nucleus just wriggle around and release release some energy, and that is in the form of a wave. So this one is actually particle, it's matter, like a little tennis ball. This one is like matter again, even smaller. So for example, a P, a high speed P moving along with a negative charge. But this one is a wave, just like light or ultraviolet. Okay. Now, what does this mean? Well, it means they have different properties. That one's obviously got the biggest mass, a mass of 4 for an alpha particle. So its mass is 4. The beta particle has a mass of almost 0. Very small, electrons are very small, very low mass compared with the mass of a proton or neutron. And this one has got a mass of 0. The charge on this one here, if we look at an alpha particle, there are 2 protons and 2 neutrons. Neutrons are neutral and protons are positive. So it has a charge of +2. The beta particle is 1 electron, so it has a charge of -1. And the gamma wave has a charge of 0. There is no charge there. Okay, so those are the properties. Let's just see how they behave now. So make sure you do need to know those. Okay, so if there's an electrical field, this one will be most affected because it's got a strong charge. If you get hit your DNA by that one, it's most damaging because the charge could change the atom, could change the makeup of your DNA. Now, if we look at what happens with these, all right, alpha particle, let's suppose it goes through some air. Okay, we've got air there. It will be stopped by the air. It gets absorbed by air. It won't go any further than that. So if you're standing a few centimetres away from alpha particles, alpha radiation, you're safe. Beta, if we have the air again, let's say the air goes right down there. This is all air, that's in the room, air. Beta will go straight through the air, and gamma will also go straight through the air. Now if we put a sheet of aluminium, thin aluminium, Al, aluminium, this will stop the beta, about 2 millimetres of aluminium, whereas the gamma will go straight through the aluminium. And the only thing really that stops gamma radiation is lead. Okay, so this is the most penetrating, this is the least penetrating. This has the strongest charge, so it's most damaging if it hits you, most ionising, and this is the least ionising. Okay, those are the main properties of 3 types of radioactivity. Thank you.